everyone, and welcome back to week 3 of Intro to iOS. Today we'll be talking about navigation, model view controller, and delegation. So first off, we want to introduce a resource to you to help with debugging constraints. And what we see here in the error message is that we have two conflicting constraints that we're trying to satisfy at the same time, but we can't. So if you were to copy your error message into why to failure autolayout.com, the site will give you a visual of the constraints you've set, and you can easily pick and choose which ones to keep or remove. So it's just like a resource to use. Yeah, so last week we covered programmatic auto layout using constraints, but there are actually a lot of different ways to lay out user interfaces in iOS, including frame-based, SwiftUI, and storyboards. For frame-based layout, we specify a rectangle to position our element. This involves setting the top, left, height, and width. For SwiftUI, we're positioning elements relative to each other by specifying the stacks, groups, lists, or alignment. And then for storyboards, we're setting constraints similarly to last lecture, but using an interface instead of code. So yeah, there's like a lot of ways to create user interfaces. However, we like to teach programmatic auto layout because it can be easily maintained across numerous people and a large code base. So now for announcements. Request an extension 24 hours in advance if you need one. Extenuating circumstances will be on a case-by-case basis, and keep in mind that not all extensions will be granted, so request them sparingly. And if you have questions, don't email us, DM a TA Gonzalo or me on Slack. And finally, grades for P1 will come out sometime whenever Gonzalo and I feel like clicking some buttons. All right, so let's review what we learned last week. How would you position a UI view in the center of a screen? In this case, the UI view being my view. So I have no idea what you picked, but the answer is E, because A centers my view horizontally and C centers my view vertically. So the combination of the two, A and C, centers my view both horizontally and vertically on our screen. And so now, moving to the bulk of our lecture, how do we create multi-view apps? Well, last week we focused on building constraints for elements within one view. However, with many apps, we see that there are multiple views that we move between. An example of this is in Eatery, where we tap on a dining hall and transition to a page that displays its hours and menu. And so this is where navigation, model view controller, or MVC, and delegation come up. Okay, so for the UI navigation controller, this is one main way to navigate between screens, and this involves pushing and popping off or on a navigation stack. And so if you're not too familiar with stacks, think of this as an array of views where you're only ever appending or removing the last element of the array. And this element is the view that we see, the last element. So in terms of code, what you would do is create a model for your view controller that you want to navigate to and push it onto the navigation stack. When you transition back from the screen, you would then pop the view from the stack, and in the code where it says animated set to true, this just specifies if we want the view to slide in or out horizontally when we transition. So it's just like a nice built-in animation. All right, so a bit of a visual example of what this looks like. We have a bunch of photo albums, and we just play this, and it'll click one, and another view controller with the album's content will be pushed onto the stack. When the back button for the albums is clicked, then the view controller is popped from the stack, and we transition back to our original screen of photo albums. So what this looks like from behind the scenes is that we have layers of different views. What we see is the assembled view to the very right. However, this is made up of a bunch of different views, like the window layered with a tab bar view, a navigation view, and a custom view hierarchy. And so on our navigation view, we have a view with clocks contained on top. If we were to push onto the navigation stack, another view would then overlay our view with the clocks. So essentially, we're layering views on top of each other and removing them as needed. All right, so another way of transitioning between screens is through modal presentation. And this does its job by presenting a view controller on top of whatever view we're on. And so there's no navigation stack, so we aren't going to be tracking the order of our views. But in terms of code, it's very similar to the push navigation where we're still creating a model for our view controller. However, instead of pushing and popping, we're now presenting and dismissing the view. And as for animations, the modal presentation will slide up from the bottom and dismiss by sliding down. Okay, so this is just another visual. Here we have Ithaca Transit, and if we just play this and click on the info button, we'll see that the About Us page will slide in from the bottom and then dismiss by sliding back down to the bottom. And yeah, so now for a model view controller, which I've mentioned previously, just throughout all these transitions, this is a very common design pattern, MVC. What this means is that we have a model with all the information we need, and upon an update, the controller will act as a middleman to tell our view what to do. Yeah, so when we interact with our view, that interaction is passed back through our controller, which performs the logic needed to update our model. And so this is a continuous cycle, which keeps our views up to date with dynamic information. Okay, so an example of MVC architecture in Ithaca Transit is having a bus stop object as a model and a view that displays these bus stops. So when the user taps on the search bar to look for a stop, that interaction is passed through the controller to identify which bus stops to display. And once the information is identified, the view will update with whichever bus stops are relevant. And yeah, so we've talked about interacting within one view and transitioning between multiple, but how do we have views that interact with each other? And that's where delegation comes in. With delegation, we create protocols similar to interfaces in Java, which can contain a bunch of methods to update our view. This allows us to call these methods from another view, and hence one object can delegate another to perform a series of actions. All right, so an example of this is ordering at a restaurant. We have a chef, customer, and menu, where the chef and customer are analogies for our objects, and the menu is a protocol. The customer wants to pass their order to the chef to create, but that order is the only information that we need to pass. And so the menu will act as a contract between the chef and customer, allowing necessary information to travel between the two. And so this is what it looks like. We have a menu delegate protocol on the top with a function make burrito. The chef knows how to make the burrito, so it conforms to our menu delegate protocol and overrides the methods within it. So we see on the left here, class chef, menu delegate, it has the function make burrito. And so on the right, we have the customer, which doesn't really care how the burrito is made, only that it is made. So the customer will have a variable of type menu delegate, allowing it to access the methods within, such as make burrito. When we order the burrito, we call delegate.makeBurrito, which notifies the chef to make the burrito. And so an important connection to make is that what do we pass as the delegate into our customer object? And so since we want our chef object, or in this case, the variable chef with lowercase c, to be making the burrito, we'll actually pass that chef as the delegate input into our customer's initializer. Okay, so you can create protocols with as many functions as needed and have multiple objects conform to the protocol. The only thing required is that when you do conform to when you do conform an object to a protocol, all the methods within the protocol must be defined in the object. So we see here that view controller conforms to change color delegate and defines its function to change color. And so you can have other view controllers also conform to change color delegate. All you really need to do is override that did change color function in whatever other view controllers that also conform to change color delegate. All right. So if we take a closer look at delegation and how we allow multiple views to communicate through a protocol, we see here that the delegate of our outer view controller is set to self. And this is because many different objects can conform to the same protocol. By setting outer view controller delegate to self, we specify that the functions of our current view controller will be called when we use our protocol in outer view controller. And so this is how you would call those protocol functions from outer view controller. Our initial view controller was passed through the delegate variable, so we have access to these functions or the delegates functions within our outer view controller through this variable weak for our delegate. So the keyword weak deals with memory management through Swift's automatic reference count arc. And this specifies that the instance can have a shorter lifetime and be deallocated even while its reference still refers to the instance. It's not something you really have to know about, just know that we specify delegates with the keyword weak. All right, and then to call our protocol functions, we would access them similarly to the functions of any other object. In this example, we say delegate dot did change color because delegate is of our protocol type. And notice here that we have the question mark because delegate is an optional. All right, demo time. Okay, so a brief overview of the starter code. We have storyboards in here which aren't used. You can delete them if you want to, but I just leave them in. Yeah, so over here in app delegate, nothing has been changed. This is the default code you get when you create a new Swift iOS project using UIKit. In scene delegate here, we've initialized a window for you with a starting view controller here. So yeah, let's take a look at this view controller. It's just a simple view with two buttons where one is going to push a new view onto the navigation stack and the other will present one. All the constraints styling has been done for you. So yeah, if we just take a look at the content here on our simulator, we have the push button on top and the present button on the bottom. Very, very simple. Yeah, so they don't really do anything right now, but we'll get to that. And so just looking at the other files, we have push view controller here. It's really simple with the title set to push. And this is just so we can demonstrate how views are pushed onto the stack. And then over here, we have present view controller. This is just a screen with a button label and text field. So for this, we want to specify that present view controller will have a placeholder text string, but we don't set it up here. So we actually have to create an initializer for it. Yeah, but other than that, everything's pretty generic. It's just some styling here, and that's when we use our placeholder text. We default our text fields text to that. Yeah, some constraints down here, and then we set up our buttons target to be dismiss view controller down here. So yeah, let's just dive into navigation. And so for that, we'll take a look at Scene Delegate here. So first up, we talked about pushing and popping views onto and off a navigation stack. And so the first thing we want to do here is create a UI navigation controller. Right now we have the Windows root view controller set to view controller here. And so in order to update this to use a navigation controller, we just do UI navigation controller. And then root view controller, set this to view controller. And so here the root view controller specifies the bottom layer of our navigation stack. We set it to view controller because we want it to default to our view controller when we haven't pushed any more views onto our stack yet. So moving on to our view controller, let's actually take a look at what this looks like. And so it's a pretty subtle change, but if we look here, there's a top bar right here. This is our navigation bar. Let's actually update it and give it a title. And so here in view controller, we can just set title equal to home. Let's run this again. And so that's something pretty cool about the navigation bar. You can customize things within it, and those components are pretty easy to set and update. But that's enough about that. Let's talk about transitioning between screens. And so for that, let's work on our push button first. So first off is pushing a new view controller. Here we see that the push button here, it has a target push view controller button pressed. And so this is what it's called when we press our push button. And so what we want to do inside push view controller button pressed is create the model of a push view controller object. So that's just let push controller. And so this is create a model, and then we want the navigation controller to push it onto its navigation stack. So let's call navigation controller dot push view controller our view controller, and then let's animate it. Okay, so here we see that the navigation controller is actually an optional, and this only works because we've set up our view controller inside a UI navigation controller within our scene delegate. So again, we have our UI navigation controller here. And so that navigation controller is what is able to push and pop the views. And all right, so let's play this. And if we click on the push button, our screen push view controller with our title push is displayed. And what's also pretty cool about UI navigation controllers is that they will come with like a back button when you push views on top. And so that back button will pop the view for you. And so if you wanted to specify this pop action without utilizing the given back button on the navigation bar, you can actually call navigation controller dot pop view controller, and then we'll just give it an animation of true. And let's take a look at this again. All right, so we push the view controller and then it'll automatically pop it, and both are animated, so this is what it looks like. All right, so let's just comment that out. And so moving on to presenting view controllers, our second way of navigating between screens, and this is done modally. So again, we have our present button here with our target present view controller button pressed, and that's what happens when we click on our present button. And so similarly to last time, we're just going to create a model object for our present view controller. So for this, we've created our initializer here with our placeholder input. So we actually have to set that to something since we're going to be using that. And so if we just go back to our initial view controller, let's set that to the title of our current navigation bar title. Yeah, so what this looks like is navigation controller dot title. And because it's an optional, we can give it a default value, and I'll just set it to an empty string. Yeah, so after that, instead of pushing the view on top, we'll present it modally. So that's just self.present. Present view controller is the controller that we want to present, and then it's given animation and no completion. All right, so let's take a look at what this does. Okay, all right, so if we click on present here, it'll present our present view controller with our label up top. We have a text field here, and then we have a save button on the bottom. So if we try to click on the save button right now, it's not going to do anything, and that's because unlike using push and popping from a navigation controller, we actually have to define this dismissal. Yeah, so back to our present view controller. Let's create the dismissal here. We just call self.dismiss, animate a true, and then completion nil again, and rerun this. Now if we present and then click save, we'll see here that the present view controller will dismiss and slide out to the bottom. Okay, so now for delegation. Let's actually communicate between the initial view controller and present view controller. Over in our present view controller, we have this text input. So why not make it so that we can change this text input and update the title of our navigation bar in the initial view controller. And so to do this, we create a protocol in view controller. Yeah, so let's call it title delegate because we're changing the title. So yeah, just give it a name, and then this will be a class. And so we'll give it a function that we can define in our view controller later. Change title, and then just some input because we want to know what that string is that we want to update the title to. And so, yeah, that's what it looks like. And let's just go ahead and update our view controller so that it conforms to that title delegate. So we can create an extension here, extension view controller, and have it be of type title delegate. And so if we just leave it here, we'll see that Xcode will tell us that we need to add these protocol stubs. And that's just making sure that all those functions that are within title delegate are overridden. And so here, because we have our navigation controller, we can just set title to new title. Okay, so now that we have that, let's take a look at present view controller. Since we actually need its text input to be passed through to our initial view controller, we're going to do this by specifying a variable up here of title delegate, our protocol, and that way we can access its functions within present view controller. So weak var delegate title. Okay, so now that we have that, we actually want to specify what this delegate is in our view controller. And so let's set that. Just before we present our view controller, we have to specify what that delegate is. So here we'll just have view controller dot delegate equal to self. And so what this does is that we want to pass our initial view controller conforming to title delegate, and we want to change its title. So we're passing self as, which is our current view controller, as a delegate into our present view controller. That way, present view controller can access this change title function down here. And so now that we have our delegate set here, if we go back to present view controller, we will call the delegate function to update our initial view controller before we dismiss this present view controller. And what this looks like is we call delegate dot change title, and yeah, so this new title string, we're going to be using our text field text. So let's just call that here, text field.text. And it is an optional, so I'm just going to default it to placeholder text. You can default it to whatever you want. But yeah, let's try this out. All right, so if we click on present here, we change our text and then save it, we'll see that the navigation bar title up here has now been changed from home to happy. And let's just try that again. Dev is awesome. We save that, we'll see that the title is changed again. And yeah, so that's a wrap for delegation. Back to the slides. Okay, so action items. Project 3 will be due this coming Sunday, March 21st at 11:59 p.m. Eastern Time. And yeah, that's all there is. Just make sure you submit it.